We are going to color our plate tectonics map today. You are going to need 3 different colors. You need a blue, a red, and a green. And I know this looks orange, but it's red. It's red. Okay, so get a blue, a red, and a green. It can be one of those really fine tip markers or an ink pen, but you need these 3 colors. We're going to start right here. So I want you to take your red and color in this section right here. This is a convergent plate boundary. This is continental crust to continental crust. Since they are very similar density, there is no true subduction taking place. And so they come into each other, and since they're of equal density, they go straight up. Okay, and so it makes your really big mountain ranges. And so this is the Himalaya mountain range right here. You have your landforms, of course, would be your really tall mountains, and you would have earthquake activity associated, of course, with this plate boundary. This is what we call a conservative plate boundary because crust is not made, nor is it destroyed here. As I said, just makes really tall mountains go straight up. So that is that type of plate boundary. Okay, now you're going to take your red, and you're going to continue along here. Okay, make that red right there. This is oceanic to continental, or I'm sorry, no it's not. It's ocean to ocean. And right here you can see this arc shape. So when ocean to ocean converge, you do have subduction. Your older oceanic crust is going to subduct under the newer oceanic crust. The older crust is cooler, and therefore it's more dense than the newer crust. And so the old will subduct under the new, and it makes these arcs. They're called island arcs, and they're full of volcanoes. As you can see, all these little dots here signify that there's volcanic activity throughout here. So subduction, you get a trench, the Java Trench, for example. You get a trench, you have subduction, you have an island arc, which is full of volcanoes. So that would be ocean to ocean convergent plate boundary. So right there. And we're going to move up through here. So all of this is subduction taking place. So you have those trenches taking place. So all of this is going to be red, convergent plate boundary. So all of this is red, and right here we have ocean to ocean again, and this is either the Aleutian Trench. This is an island arc. These are Aleutian Islands that are off of the coast of Alaska. So Aleutian Islands. And it comes down, but not all the way down here. So it comes down, and then you notice how it has just a little divot in, makes somewhat of a triangle shape right there. So all of that right here, this is going to be oceanic to continental. And so along here you have this mountain range that is formed along the edge of this mountain, or edge of this continent. So where this plate boundary meets. And these are also full of volcanic. So you have your volcanic mountain range along here. You have your island arc along here, ocean to ocean, ocean to continental, ocean to ocean. You have your islands that are being formed because of that plate boundary. Okay, I need you to come right down in here. And you see there's another island arc right here. Okay, this is like the Polynesian Islands right in through there. And it continues up through here. You have Micronesia, all this area here. This is an island arc that's formed due to ocean plate boundary. Right? So we're going to move over here. We have that going on right there. And all down the coast of South America here. This is the Andes mountain range that's formed along the west coast of South America. It goes all the way down full of volcanoes all the way through there because subduction is taking place. You have a trench, subduction, volcanic mountain range taking place right there, all down South America. And you have that trench up here also. The Marianas Trench is in this area, and right now we know it's the deepest trench in the world at this point. Okay, so now we're going to slide over just a little bit. You have a little section right here. You see that island arc right there, ocean to ocean. And along the top of the Arabian Plate here, okay, so along the top of the Arabian Plate there is convergent plate boundary. So these are different areas that have the convergent plate boundary. So you need to make sure you have those marked. There are three types of convergent. You have your three types of convergent plate boundary. So you have the one here, which is continental to continental. So continental, mountain range, earthquake activity. Right here is ocean to ocean. You have your island arc, trenches, volcanic islands, earthquake activity. Okay. Ocean to ocean again, your island arc, earthquake activity, volcanoes. Right here, you're going to have that mountain range that is formed that has volcanoes in it. You will have a trench all along there, earthquake activity. So here, crust is not made or destroyed. Anytime you have subduction, crust is continuously being destroyed. That's why we call it a destructive plate boundary, because crust is destroyed because of it. Okay, so convergent plate boundary, convergent plate boundary. Okay, so those are areas of convergent plate boundary. So the next one we're going to do is our divergent plate boundary. Okay, our divergent plate boundary is when the plate is moving away from each other. And so all through here is divergent. So we're going to color all this green. Green is going to stand for our divergent. There's also, along the divergent, which is why it looks the way it does, some transform boundaries. Kind of broken up looking, but these are divergent. So give it just a green outline. And there's a little bit of one up here. Okay, so this is green, and this is green, and this is green here. And this is going to be green. So these are divergent plate boundaries. And there is actually in the United States a small divergent boundary going along the Rocky Mountain Range too. Okay, so divergent, all of this is divergent. So we're just going to make that green so we know that shows up as divergent. Okay, the mid-ocean ridge is all down here. So all of this goes through Iceland there. All of this, the mid-ocean ridge, is divergent. And you remember from your notes that the mid-ocean ridge is the longest mountain chain in the world. It is all completely underwater. Now when you get up to Iceland, you can actually walk on the mid-ocean ridge, and at some point in time, poor Iceland is going to be broken into several pieces. So along the mid-ocean ridge, we call it a constructive plate boundary, because as the oceanic plate is sliding away from each other, as it pulling away, magma constantly erupts onto the oceanic floor, and it's making new crust. And so we call a divergent boundary a constructive boundary due to the fact that new crust is being created because of this boundary. There's also all through here, this is a divergent boundary, and this is on continental crust, and this causes that Rift Valley. And there is new crust being made there too. You can see all the little volcanoes. There's mountains, there's volcanoes all along here also. Mountain ranges being formed as that crust just builds up and builds up. At some point in time, all of this is going to move apart. If you look at a map, you will see a chain of lakes that follow up through here. And eventually these lakes will become a shallow sea, and then it could become a full-blown ocean. Eventually, in, of course, geologic time is millions of years from now. So all this is divergent. So mid-ocean ridge, longest mountain chain in the world, new crust constantly being made. So due to the fact that this is dividing, the Atlantic Ocean is getting larger. So the Atlantic Ocean is growing, whereas on the other side, the Pacific Ocean is actually getting smaller, because you have all these areas of subduction. Not much subduction taking place over here. Lots of subduction taking place in the Pacific Ocean. So the Pacific Ocean is gradually getting smaller, whereas the Atlantic Ocean is gradually getting larger. Okay, so divergent oceanic crust, new crust constantly being made. You have this ridge that is formed, earthquake activity, volcanoes. If it is on continental crust, it's called a rift. It makes a rift valley. You have volcanic activity. You do have some new crust being created, but just not at the same rate as your oceanic divergent plate boundary. So these are divergent, is your green. We're going to get our blue. Okay, our blue is going to be transform. So right here, there's actually a type of transform boundary right there, and a very famous one right here, which is the San Andreas Fault. So transform boundary. Believe it or not, the San Andreas Fault is only like one of two or three that would be up on the continental crust. Most of your transform boundaries are actually in your oceans. There's a transform boundary that runs along here, and you can see a little bit of it right there. Transform boundary, that's the other place. And one right there. So transform boundary, in all these there are transform boundaries that's along here. That's why you have these jagged looking marks, but these are your main ones. Okay, so remember, on transform boundary, no volcanoes, no landforms are being made per se, other than a fault line, which is that big crack in Earth's surface. So you have a fault line and lots of earthquake activity. Okay, so transform boundary, lots of earthquake activity, fault line. So we're going to draw in this particular case, the Pacific plate is moving in a northwesterly direction, and the North American plate is moving in a southeasterly direction beside each other. So that's the direction that those are moving in. And this is the really famous one with San Andreas Fault. A lot of activity in California due to the San Andreas Fault. These are divergent, so show them moving away from each other. So divergent plate boundary, the boundaries, they are moving away from each other. So we're going to draw some arrows just showing them that it is dividing. Okay, so those are our three main types of plate boundaries. You have divergent, which if it's oceanic crust, you're constantly getting new oceanic crust, so it's constructive plate boundary, new crust is being made. You have that ridge, volcanoes, earthquakes. If it is a divergent boundary that's on continental crust, you get a rift valley, volcanoes, mountains, earthquakes, new crust. You have three types of convergent plate boundaries. You have continental to continental, the continental to continental, mountain ranges, earthquakes. If it is ocean to ocean, you have your island arcs, which are full of volcanoes. It's volcanic island arcs, trenches, earthquakes, that subduction zone. If it is continental to oceanic, you're going to have that mountain range. It's right along that plate boundary. Out here, you're going to have a giant trench, and you're going to have that mountain range that goes along that plate boundary on the continental crust, and it's going to be full of volcanoes. So it's a volcanic mountain range. So trench, subduction, volcanic mountain range, earthquakes. Same that's going on up here and there. Okay, so you have three types. You have continental. It is a conservative plate boundary. Crust is neither made nor destroyed. You have ocean to ocean, and you have ocean to continental. Both of these are destructive in that due to the subduction, crust is destroyed. Then you have your transformed plate boundary, where you have a fault line that is created, lots of earthquake activity on that one. Okay, you have Hawaii here, and you notice it says hotspot. Okay, and you notice there are no plate boundaries around Hawaii. So Hawaii is a hotspot volcano, which is a special case. And what happens is there is a weakened area that's allowing the magma to come up through. And so as this plate, you see it's shifting that direction. As it shifts, one, it's going to break off, and the island will move away. And as this one is moving away, a new island is constantly being made, and so you get that chain of islands, and you can see the direction the plate's moving by seeing where the oldest island is and where the newest island is. You know that it is moving that direction. And we know that there is another island forming out here off the coast of the main island of Hawaii. So hot spot, so there's a hot spot there, and of course the Yellowstone is a hot spot volcano also. Okay, so you're going to take this, and once you have it labeled, you've drawn your arrows, you've colored everything, you're going to take your journal, and I've already got my notes taped in, and you're going to tape it into your journal. I don't think it'll fit that way. It'll fit that way. Okay, so you're going to tape it in your journal. And you have a title, and at this point we should have all our three types of plates marked, and you're going to make a key. So I'm going to put convergent, boundary, divergent, boundary, and transform. Okay, remember our convergent, we did red, so I'm just going to put a red. Our divergent, we did in green. And our transform, we did in blue. So we've made a little key that shows what each of those colors represent. Okay, don't forget to add this to your table of contents. Don't forget to put your date at the top.